Hello guys, welcome back to my channel. Mason African Motives are still working on mathematics O level. So in this platform we are going to have a consideration that you're going to have look at working on questions on inverse variation. So if you are to consider this we once worked with variation before, it's just a matter of adding more questions. Okay, so anyways, that's it guys. Make sure that if you're new, consider subscribing so that you won't miss any of the classes that we shall be having from Mason African Motives. So like I was saying, inverse variation. So I'm going to focus on the questions which were taken actually from New General Mathematics book 4. So I just selected one or two questions from exercise 9C. So before I refer to these questions, I'm just going to explain one or two things about this inverse. But we talked about this in our previous classes, okay? Where I was saying that if you are given inverse variation, you are given such a consideration like this. Okay, sorry for that. That is A varies inversely. This one, A varies inversely as B in words. This part here, as we are given 1 over, it means A varies inversely as B, or inversely with B, or A is inversely proportional. A is inversely proportional to B. Okay, it's another way that they can give you. So once you're given this in words, you have to rewrite this in this format here. Then what's the next thing? Just like in direct variation, you have to introduce the equal sign and the constant. So the moment you introduce the equal sign and the constant, it will be K over B like this. That's what you're going to have. It can be K over the square root of B. It can be K over whatever that they give you. It can be B to the exponent of 2, but it's going to be K over, which is opposing what you had on direct variation like this, where you were multiplying K and B were multiplying. This time you are dividing. So that means when B, if this B increases, this A is going to reduce because they are inversely proportional. If B decreases, A is going to increase. That is the concept. So it's inverse to each other. So where on direct, if this one increases, this one increases. If this one decreases, this one decreases. But here it's opposite to that concept. Okay, so just like in direct variation, you have to find the value of the constant so that you can find the relationship between the two variables or whatever variables that you be given. So that case is still one and the same thing with the previous one. So let's just consider one or two questions here. So from exercise 9C from NGM book 4, I'm given the first question on number 4, which reads that if X varies inversely as Y, so that one is not inversely as 1 over Y, no. 1 over Y, it means inverse. So when you read it, it's X varies inversely as Y, okay. And X is equal to 2 when Y is equal to 3. Find the relationship between X and Y. So you need the relationship between X and Y. So like direct variation, you still have to consider the same thing here, guys. X varies inversely as what? As Y, like this. So remember, the first thing is to introduce the constant. So X is equal to, the moment you introduce the constant, you're introducing also the equal sign, okay? Then to find, so this is a relationship, or it's an equation which connect X here, Y and K. But we need an equation where the only letters that can be indicated it's X and Y. This is what they need here, X and Y only. So it means you have to get rid of this K. You need to substitute to find the value of K, because we are given X is 22 here. So in place of X, you can substitute 22. 22 is equal to K over the value of Y. The value of Y in this case is 3. So you're given the value of Y as 3. So it's going to be over 3 like this. So let's cross multiply, guys, and see what you're going to have. It's now a normal equation. So this is a fraction, so it can be a whole number. So as a fraction is over 1 like this. So you can cross multiply. That's this and this side, so it's 3 by 22, which is 66, which is equal to 1 times k, which is equal to k. Okay, so the value of k is not a relationship, but that's the constant which connects the two variables x and y. So x and y, these are the variables, and this one is a constant. So in place of the constant, you are now going to substitute the constant value, which is 66, in place of k here over y. Okay, so this is now the relationship between x and y. As you can see, the only letters that you have, it's x and y. You only have x and y. That is x and what and y. You must have letter x and letter y only, not k. K is a letter, so when you write this, it's a relationship between x and y and a constant k and a constant. So this one will have a constant k, but this one, it's x and y only. So that's it, guys. Let's see another question on number 6. So if you have to consider number 5, it was just one and the same thing. So on number 6, now we are given this as a word question, like word problem now. So still you have to apply the same thing. If y varies inversely as x, so let's start by that. Y varies inversely as x. How are you going to write this? Okay, that's number 6. Y, we said when it varies inversely, it's going to be 1 over, so it varies inversely as x, so it's 1 over x. Okay, then, and y is 2 when x is 3. Find y when x is equal to 6. Okay, guys, what are they trying to say here? How can I find the value of y when x is equal to 6? How? When I'm just given this information. Okay, these guys, they're very clever. They miss some of the questions so that you don't think about those questions. You cannot find the value of y when x is equal to 6 without the relationship. So you actually need the relationship here between x and what? Between x and y. So you need the relationship. Okay, so first is to find, where do you find the relationship from this information, this full information that you are given. Y is 2 when these two, they are connected, guys. Look at this. Y is equal to 2 when x is equal to 3. So these two, they are moving, or they are connected together. Then find y when x, which means there's another problem which is going to be solved after you work with these two values first. Okay, so relationship, remember, you have to introduce the equal sign and the constant at the same time. Okay, then let's substitute y is equal to 2 when x is equal to 3. Okay, 2 when x is equal to 3. So just like the previous part, we can cross multiply. This is like over 1, so it's 3 and 2, 1 and k, like this. So 3 times 2, that's 6, 1 times k, which is k. So now the relationship, we need the relationship. So it's going to be y is equal to, in place of k, you substitute 6. So it's 6 over x, like this. Okay, but this is not the answer actually, because the question is find y when x is equal to 6. So what you're going to do, you continue from the relationship, you substitute now the value of x. So you see this importance of substitution part that we talked about as a subtopic of substitution. So you're simply substituting, in place of x, you substitute 6 on this relationship. So y is going to be 6 over x, which is 6. So y is going to be 6 over 6, which is 1. So that would be the value of y, guys, when x is equal to 6. So that's the value there. So as you can see, sometimes they might skip a condition of the relationship and just ask you the question direct. Guys, you must be very, very careful. Okay, let's see what you're having on exercise 9c. Number 8, still on exercise 9c, there's a number 8. This question I've taken, it's very, very important, guys. Do not take this question for granted. If x varies inversely as the square, take note, as the square of y, as the square of y, and x is equal to 4 when y is equal to 1 over 2, what is y when x is 5? So as you can see, this one is a similar question to the one that you had, that they just ask you a question like this: what is the value of this where this is equal to this? But how can we just attempt this question? We need the relationship. There is no way. First we need the relationship. So let's start here. X varies inversely, so that's something like this. Okay, this is number 8. So it's x like this, varies inversely. That's 1 over, what do we have here? As the square. This is not the square root, but the square like this, to the exponent of 2 to the power of 2. That is square. Square root, that is square root. This is square root like this. This one, it's a square. So the square of y is y squared like this. Okay. Introduce the constant and the equal sign at the same time. X is equal to k over y squared. Okay, so we need the relationship, so definitely we have to substitute the values that we are given. We are given the value of x, which is 4, when y is equal to 1 over 2. So x is 4. So in place of x we have 4, which is equal to k over y squared. Well, y, it's 1 over 2, but there is a square here, so it's 1 over 2 to the power of 2 like this. Substitute properly. Okay, if you are to cross check, guys, you are going to obtain 4, which is equal to k over, this is a bracket, so everything is going to be raised to the power of 2. So it's 1 to the power of 2, which is 1, 2 to the power of 2, which is 2 times 2, which is 4, so it's 1 over 4. So just like the previous part, you have to cross multiply. So this multiplies this and this multiplies this. So it's 4 times 1 over 4, something like this, 4 times 1 over 4, which is 1, because this one 4 and 4 cancel. So this is 1 is equal to 1 times k is equal to 1, guys. These values are connected when k is equal to 1. Interesting. Anyways, so x is equal to 1 over y squared. Let's see how interesting this question is when k is equal to 1. Are we seeing some interesting part, guys, or maths should be interesting some more, guys? Okay, anyways, if it is not interesting, one day it will, as we are working with Meson African motifs, you'll find it more interesting someday. Okay, I have the relationship between x and y. Then what follows now? What is y? This question, I'm now answering this. So are you seeing that I was like, I'm diverting, I'm running away from the question. The question is going this way, I'm going this way. So that is important, guys. It's not about directly going to the question and answering the question like that. Oh no, it can't be like that. You have to consider the steps which are needed when you're answering these questions. Okay, so let's find now the value of y when x is equal to 5. I'm just going to substitute here. In place of x I have 5, so it's something like this. In place of x I have 5, so 5 is equal to 1 over y squared. Now how can I find y? So definitely I have to cross multiply, because 5 is same as 5 over 1. Cross multiply just like previous ways to remove a fraction. So it's 5 times y squared, which is 5y squared is equal to 1. 1 times 1, that's 1. So not so it's going to be 1. This one and this one, 5y squared. Then 2, as you can see, now you have 5y squared. So remember, to have y squared here, you divide by 5 both sides, you divide by 5 both sides, like this. So if you divide by 5 both sides, you are going to remain with y squared, which is equal to 1 over 5. Guys, at this stage, please be careful how you answer your question. This is y squared. You need to find the value of y. So to remove the square, you introduce the square root. To remove this square, you introduce the square root both sides. The moment you introduce the square root both sides, you have eliminated, or you have removed these 2, so you're now left with y, which is the square root of 1 over 5. So this question now, they are treating this from your sides. Remember, guys, from your sides you can actually find the square root of 5, the square root of 1. You can find the square root of what? The square root of 5 by square root of 1 is 1 over the square root of 5. I can't find this square root of 5 direct, so it's just going to remain like square root of 5 like this. But we know that from our sides it's not allowed to leave the answer like this, so you have to rationalize by square root of 5 over square root of 5. So square root of 5 times 1 which is square root of 5 over square root of 5 times square root of 5, which is 2. Or actually you can just write this as a decimal, depending, maybe it's in paper 1. So if it is in paper 1, you have to rationalize. If it is in paper 2, you just need to use your calculator, okay? Square root of 1 over 5, using your calculator like this, square root, then you put a fraction, that's square root, then you put a fraction. This light is too much, that's why I'm not putting this whole calculator like that. So it's 1 over 5 like that, 1 over square root of 5, okay, 1 over square root of 5. So it's going to be 0.68, something like that, as a decimal. So you can write it as a decimal, or you can just leave it like that. Okay, so that's how they ask these questions, guys. So it's not a matter of like being worried about how is this answer like this from my answers in book 4, they are like this. No, it's one and the same thing. So just like this one, but this time we have the square root. Now p varies inversely as the square root of v. So let's start with this part first. Okay, we have p which varies inversely. We said it's 1 over, and this one is the square root as the square root of what? Of v. So it's going to be the square root of v like this as a square root. That's what you're going to have. Okay, now introduce the equal sign and the constant at the same time, which is the square root of v like this. Okay, now what the question is saying, you're given the value of p, the value of v, find v when p is equal. You see these guys, they are so crazy. How can you just ask this question? There must be but if you are to cross check when you're answering paper 1, even paper 2, they on question papers they ask these questions in stages. That is why I advise you guys not only to work with NGM book 4 and book 3, but also to work with question papers so that you know how they ask these questions. Okay, so on questions like this, you need the relationship first. So you have to substitute the value of p and q. So p is 4,5, p is 4,5, which is equal to k over the square root of v. Okay, so the square root of v, this is your v, which is 25. So you have to substitute that value here, which is in the square root. Okay, taking note that the square root of 25 is 5. Square root of 25 gives us 5. Actually, it's plus or minus, but when you're working with these, when you're working with these values, just use positive values. Like you are still calculating like this. But on your final answer, like you have a condition where it's needed to find the square. That's where you can apply the plus or minus. But when you are still working, use positive values, okay? So 4,5 is equal to k over the square root of 25, which is 5, okay? So just like the previous part, I'm going to cross multiply. Okay, so if I cross multiply here, it's actually this side and this side multiplying. So 4,5 times 5, it's actually 4,5 as a fraction, guys. This is 45 over 10. That's 45 over 10, which is by 5 is going to give us 9. By 5 we are going to obtain 2. So it was like this actually, 9 over 2. So you can write this as a fraction so that you don't confuse working with decimals, guys. So this one is actually 9 over 2. Let's just write this as a fraction. 9 over 2 is equal to k over 5. Okay, so I haven't changed, guys, please take note. I haven't changed anything here. I haven't changed anything. I just rewrote this as a fraction, which is one and the same thing. Okay, now let's cross multiply and see what you're going to have. So it's 5 times 9, which is 45, is equal to 2 times k, which is 2k. Divide by 2, divide by 2. So that's k, which is equal to 45 over 2. Okay, so we have the relation, we have the k, but we need the relationship. So we substitute the value of k here. So it's going to be like, hey, this is going to be weird. Anyways, p is equal to k, which is 45 over 2. So it was supposed to be like this, guys. So it was supposed to be like this. Let me write it. So it was supposed to be 45 over 2 like this. This is your k over the square root of v like this. This was supposed to be like the presentation, but guys, this does not like sound well in mathematics. Okay, I want you to teach you something here. When you are given 2 over 3 like this over v, it simply means 2 over 3 v. These ones, they multiply, the denominator and denominator multiplies each other. Okay, so in this case, this presentation can be like this. The denominator and denominator multiplies each other. So it's going to be 45 over 2 square root of v. That's a better presentation that you can do like this. So denominator and denominator multiplies each other. So I have the relationship of p and v. The question is find v when p is equal to 15. So I need to find the value of p, the value of v when p is equal to 15. So I have to substitute in place of p, I have to substitute 15. So it's 15 is equal to 45 over 2 square root of v, and I need to find the value of v in this case. Okay, so let's cross multiply and see what you're going to have, because this is same as over 1. So if you cross multiply 15 and 2 multiply, so it's 15 times 2, which is 30 square root of v, which is equal to 1 times 45, that is 45. Okay, let's work out this together, guys. We have to divide by 30 by 30, divide by 30. Mostly these are in paper 1, that's why I'm showing all these working, because mostly it's paper 1. So you cancel this. Square root of v is going to be, you can reduce by 5, that is 9, by 5, that is 6. Then you reduce again by 3, that is 3, by 3, that is 2. So you're going to have 3 over 2 as a reduced fraction. But this is square root of v, take note, square root. So you saw last time we removed the square by introducing the square root. So it means if there is a square root, you oppose, you remove it with a square. So this time you square both sides like this. Okay, so the moment you square both sides, you're actually removing the square root, which means you're now left with the v, which is equal to 3 squared, that's 3 to the power of 2, which is 9 over 2 to the power of 2. Everything has to be raised to the power of 2. So 3 to the power of 2, 9, 2 to the power of 2, which is 4. So your v is going to be 9 over 4, which can be actually 2 and 1 over 4. If you want to write it like this. So guys, somehow you do not run away from these questions. If they are in paper 1, there is no way you are alone, there's no calculator. So just learn to be faithful with yourself and use calculator when it is required. When the calculator is not required, please be faithful with yourself. Do not use a calculator. You are actually, what can I say, you know what I'm trying to say. So please just try to revise without a calculator when the calculator is not needed, when you are revising for paper 1. But for paper 2, please do use your calculator to the fullest, to the maximum. When there is a need for a calculator, use it. When there is no need, do not. So that is the idea there, so that you actually pass out these questions and you know basic questions. So that's it, guys, from Mason African Motives, working on revisions from our textbooks and question papers. So if there are some areas that you know that we still haven't worked on, or we have worked on them but they're still giving us a challenge, let me know in the comment section so that we can work on them. So till we meet again.